As of September 5, 2027, Voyager 1 will have been on its journey through space for an astonishing 50 years. Launched in 1977, it has since raced past the outer planets, entered interstellar space, and now speeds away from the Sun at over 38,000 miles per hour. At that point in time, it will be more than 24 light hours, or 176 astronomical units, away from our star. And yet, in cosmic terms, it will still be in our solar neighborhood. If it maintains its current pace, Voyager 1 will take about 300 years just to reach the inner edge of the Oort cloud, a distant shell of icy objects believed to encircle the solar system. To reach another star system? That would take around 40,000 years. And yet, we continue to listen. We continue to track. Because Voyager 1 is no ordinary spacecraft. It is, in many ways, the most extraordinary message in a bottle humanity has ever launched into the cosmic sea. But to understand where it's going, we must first understand where it's been. Voyager 1's original mission was ambitious. Fly by Jupiter and Saturn to gather never-before-seen data and images. And it delivered. When it reached Jupiter in 1979, it unveiled a chaotic masterpiece of swirling storms and intricate cloud bands. It gave us our most detailed early view of the Great Red Spot, a centuries-old storm larger than Earth itself. And when it turned its lens toward Jupiter's moons, it made groundbreaking discoveries. Chief among them, that Io is the most volcanically active body in the solar system, and that Europa might harbor a subsurface ocean beneath its icy crust. The revelations continued as Voyager 1 reached Saturn in 1980. The spacecraft's images revealed an astonishing complexity in the planet's rings, countless ringlets and gaps, including the elusive F-ring, previously unseen. Saturn's moons were equally captivating, especially Titan, shrouded in a thick orange atmosphere rich in nitrogen and organic molecules. This hinted at prebiotic chemistry, complex carbon-based compounds that might resemble the building blocks of life. But the most poetic moment came in 1990, when Voyager 1, having completed its planetary mission, looked back and captured the pale blue dot, a tiny speck suspended in a sunbeam. That faint blue pixel was Earth, as seen from 3.7 billion miles away. It was Carl Sagan who said, "That's here, that's home, that's us." After that, the Voyager interstellar mission began. Voyager 1 continued outward, passing Pioneer 10 in 1998 to become the farthest human-made object in history. And on August 25, 2012, it crossed the heliopause, the boundary where the solar wind meets the interstellar medium, becoming the first spacecraft to enter interstellar space. Even now, it transmits data using a 3.7-meter high-gain antenna, sending signals that take roughly 20 hours to reach Earth. It communicates via NASA's Deep Space Network, massive dishes spread across California, Spain, and Australia, each working together to maintain a line of sight with spacecraft billions of miles away. Its power, however, is finite. Voyager 1 is powered by radioisotope thermoelectric generators, RTGs, which convert heat from the decay of plutonium-238 into electricity. With a half-life of nearly 88 years, the RTGs lose about 4 watts of power per year. By 2025, the spacecraft will no longer have enough energy to operate its instruments or communicate. After that, Voyager 1 will drift silently through the void, its mission complete, its signal gone, but its journey still ongoing. Yet even in that silence, it carries a message: the golden record. A 12-inch gold-plated copper disc, encoded with music, greetings in 55 languages, natural sounds, and images from Earth. A snapshot of humanity, a whisper to the cosmos, a timeless gesture of hope. But can Voyager 1 go on forever? Theoretically, yes. Barring a collision with a large object, Voyager 1 may drift for billions of years. It may suffer damage from micrometeoroid impacts or cosmic radiation, but its basic structure could remain intact long after the Earth itself has ceased to exist. Over that time, it could travel nearly a quintillion miles, roughly 1.7% of the Milky Way's diameter. Its projected trajectory takes it toward the constellation Ophiuchus, and over millions of years it may pass near other stellar neighborhoods like Hercules, Lyra, Cygnus, Draco, and Camelopardalis. These regions contain thousands, possibly tens of thousands of stars, silent witnesses to Voyager's passage. But over such timescales, the galaxy itself will change. Constellations will morph or disappear as stars are born and die. Gravity from molecular clouds, passing stars, or even nearby galaxies will nudge Voyager 1's path in subtle but cumulative ways. Eventually, its journey may become as unpredictable as it is eternal. And yet, that's the poetry of Voyager 1. Not just where it's going, but what it means. It's a silent explorer that embodies the essence of human curiosity. Long after its power fades, long after Earth falls silent, Voyager 1 will continue to carry our story into the dark, an interstellar ambassador of a species that once looked up and wondered,